remember about absolute value? You said nothing. Yeah, Omar, what do you got, buddy?
They always end up in positive form.
So it's always positive. Okay.
How about 25 minutes left when it's 2:50?
We got here at 3:15, right?
20.
Oh, 3:10. Sorry, 20 minutes left. Yeah. Yeah. What else you got?
So we have to take the positive and negative value of your answer.
Okay, interesting. What else do you have? What's it look like? The symbol, yeah, 2 bars. It looks like this, right? Absolute value of x, right?
Bars.
Okay. What does it mean?
It's like 2 bars.
Yeah, Adrian. There you go. It means, it means a distance from 0, right? Why is this being not fun? From 0, but 0, right? On the number line. There you go. And what else? If I gave you the absolute value of -3, what would you tell me the answer would be?
3.
Yeah, +3, right? Okay, so there's some review of some key things about absolute value. Okay. So what if I gave you the absolute value of x was equal to 5? Okay, and we looked at this on the graph. Okay, what would your number line? What would it look like here? Here's that, right? Here's 0. How many solutions are there to this particular little equation?
2.
You say 2. Which ones are they? What are they?
-5 and 5.
Yeah, -5 and +5, right? So there are 2 answers that are 5 units away from 0, right? So therefore, the absolute value of x equals 5. I can split this off and go 2 directions, right? I can have 2 answers. I can have, well, x could either be 5 or x could be -5. So I've got 2 answers there, and there's an or statement there.
Can you write in the solution set?
Yeah, you could. Yeah, 5 or -5. That's it, right? Okay, so that leads us into the third box, which is how do we solve these things? We are. Okay, so the question is, how do we solve an equation involving absolute value? So you're going to be presented with things that look like this. So ax plus b in absolute value is equal to c, where the c is greater than 0. Why is this important? Why is c greater than 0? Why is that important? It has to be positive, right? Absolute value can't be negative, so we have to set it greater than 0. Nice job, Olivia. So that means what we do, okay, is we split off our problem into 2 separate problems, a positive direction and a negative direction. So that means that ax plus b would equal positive c, and then ax plus b would equal negative c, just like we solved this little example up here, right? Because everyone said, oh, the answer is 5 or -5. They seem to get that intuitively, right? But when you start putting equations in there, people seem to not figure out exactly what to do. Now, this part over here sometimes makes people a little upset. Can you see why? Yeah, Daniel.
Well, didn't you just say it had to be greater than 0?
That's right. I said it had to be greater than 0. But what do you notice that's different between the first thing you got, and then down here? What's the difference? There's no more absolute value sign, right? So now we're talking about a value that we can plug in to make our original statement true. So I'm not setting absolute value equal to negative number. I'm setting the value that I can solve to get for x to plug it back in. Yes?
But negative c is not greater than 0.
Yes, I realize that. I'm saying the original up here, the original c has to be greater than 0. Yeah. All right. Now, a little reminder. Okay, you need to get the absolute value of ax plus b by itself before you split. So make sure you get the absolute value part by itself before you split it off into 2 directions. Okay, here is an example. We're going to solve this one together, okay? We're going to solve the absolute value of 6x minus 3 is equal to 15. All right, so far so good. I'm noticing that the absolute value part is by itself, so I can go ahead and split this into 2 parts right away. So 6x minus 3 must be positive 15, or 6x minus 3 must be negative 15. Doing some algebra, 6x has to be 18, therefore x must be 3. So that's one of my solutions. But this is an OR statement, so don't forget that. So that means that 6x could also be negative 12, so x could be negative 2. So I seem to have two answers that make my original absolute value true. And so we can check that easily equal to 8. Okay, so in this one, you can see that you have to do something before you split off to the positive and then negative direction. Do you see what it is? Got 2 or negative 9 from that. That's what I'm talking about. Nice job. So 2 and negative 9 were the solutions to that one. I'm glad that you moved the 3 over before you split off. Okay, now we have to talk to you about solving absolute value inequalities. So it's the same thing as before, except I'm changing equations to inequalities. Okay. Now there are two situations here. Okay. I'm gonna give you both of them, and I don't want you to mess it up. Here's the first one. Here's the second one. Okay. And I'm gonna draw a line right down the middle so we can compare the two. Okay. So absolute value inequalities. There's two situations. The first situation is this: you could have the absolute value of ax plus b is less than c, where c is a positive number. Or you could have this situation. The absolute value of ax plus b is greater than c, where c is greater than 0, because otherwise you end up with all real numbers. Okay, so two situations here. Noticing on the first one, what does that inequality say? That says less than, right? And notice I'm emphasizing the and. Less than. This creates an and statement. You've heard this before, right? Now over here, what does that seem to be? Oh yeah, that is a great Greator. I misspelled it on purpose. Greator, right? This creates an or statement. And statements, as you know, are compounded. Or statements, as you know, split off like little oars on the side of a boat. So, then I'll just keep going with this, okay? So, here's the part that you cannot mess up. The setup. Okay, here is the setup, okay? When you have a less than statement, which is an and statement, it's a compound statement. The setup is this. Negative c is less than ax plus b less than positive c. Okay? When you see this, this is the setup. Okay? Versus the other one, okay, the setup is a two-part. 1, 2. The two-part is this. The first part is ax plus b is just greater than c, or ax plus b is less than negative c. I'm sorry I ran out of room there. There we go. Move it up for you. There you go. Like that. So that very, very important. Very, very important, okay? The easiest way to get this wrong is this is what most people do. Maybe you already know. They take this stuff and they set it up like that. And they take this stuff and they set it up like that. So they get them crisscrossed, right? This is the -- mistake that students make. So your goal is to not be that student who makes that mistake, okay? Because every year it happens, right? They set it up differently. They set up the greater than one like this, and they set up the less than one like that. So that is a mistake. So I'm going to get rid of that because I don't want you guys to make. Okay. The absolute value of 4x minus 9 is less than 21. So which situation are we dealing with, people? Less than or greater than? It's less than or equal to. Yeah, it doesn't matter. We still treat it the same way as a less than. Okay? So, how are we going to set it up? There you go. So, negative 21 is less than or equal to 4x minus 9 less than or equal to positive 21. You guys still with me? Yep, that's how you set it up. Get rid of the plus 9 everywhere. So that means that negative 12 is less than or equal to 4x, which is less than or equal to 30. So I'm going fast because we're running out of time. So divided by 4. So that means negative 3 is less than or equal to x, less than or equal to 7.5. So notice a less than statement has created a compound inequality, right? So here's negative 3, here's 0, here's 7.5, and I want brackets, and I want everything shaded in between them. Okay, so we have 3x minus 2 plus 3 is greater than or equal to 11. So the first thing I do is take care of this part, right? Greater than or equal to 8? 8, 9, yeah, 8, yeah, okay. Now that I have that, I split this off into two situations, 1 and 2. The first one is 3x minus 2 is greater than or equal to 8, or 3x minus 2 is less than or equal to negative 8, and we solve both of these. In doing so, I come up with x is greater than or equal to 10/3, or x is less than or equal to negative 2. I'm sorry I didn't show you the algebra on that, but I want to fit it in. So that means here is 0, there's negative 2, and over here is 10/3, right? So I want everything that's greater than or equal to 10/3, so I want this stuff. Less than or equal to negative 2, so I want that stuff. So notice I have a or statement going off in either direction. Okay, any questions about that? Sorry again, that was super, super fast, but I wanted to make sure we got it in before the day ended.